Hello and welcome to the another tutorial of this Blockzie module. Here we make your coding journey easy and fun. So in the previous lecture we have seen the different sensors interfacing with Arduino Uno in Blockzie. So now it's time for us to build a circuit and make something new. So in this tutorial we are here with a clap switch circuit. So we are going to make a clap switch circuit using Arduino Uno microphone sensor and some other devices and also block coding in Blockzie. So in this particular tutorial we are going to learn about how to make clap switch circuit with Arduino Uno and in Blockzie. So the table of content for this tutorial is divided into two different parts. The first one is the introduction of microphone sensor, and in the second part we are going to see the clap switch circuit in detail. So first is the introduction part. So let us first start with seeing that what is microphone sensor or sound sensor. So as you can guess from its name that a sound sensor means a sensor which senses sound in the surrounding medium, right? So a microphone sensor, which is also known as a sound sensor or sound detector, is an electronic device that converts the sound waves into electrical signals. So it is a kind of sensor which is first going to detect the sound in the air, and after that what it will do, it will convert that sound waves into electrical signals. So a sound sensor is a simple, easy to use and low cost device that is used to detect sound waves traveling through the air. It can also measure its intensity, and most importantly, it converts the sound waves into an electrical signal that we can read through a microcontroller. So the converted electrical signals, we can see that or we can read that in using a microcontroller. So, microphone sensors are widely used in industries such as telecommunications, audio recordings, speech recognition, and many more. So, in telecommunications, also in audio recording and speech recognition, this kind of sensors are used where you need to convert the sound waves and get the information. So, we use this kind of microphone sensor or sound sensor. Let us quickly discuss its feature. So the features of this particular microphone sensors are as here. First of all, its operating voltage. So it can operate from 3.3 volt to 5 volt DC. It has LM393 comparator. Also, the PCB size of this module is of 3.4 centimeter cross 1.6 centimeter, and its induction distance is of zero point 0.5 meter. It requires the operating current of 4 milliampere. Microphone sensitivity means this particular component's sensitivity in 1 kilohertz is from 52 to 48 decibels. It is easy to use with microcontroller or even with normal digital and analog integrated circuits. The sensitivity of this particular module is very high, and electric condenser microphone. Also the low level output signal used for sound control light. This is the schematic diagram of microphone sensor. So we will see the components, or you can say the onboard components. So first of all, there are four pins. As you can see here that it the module has four pins, and they are namely as DO means digital output pin. After that we have plus means it is a power pin, which is also known as VCC pin. After that is a ground pin, and this is A0, which is analog pin. It has power LED. Power LED means when you connect your sound sensor or this microphone sensor with the microcontroller, it will be on, or the LED particularly over here will turn on, which will indicate that the component or the module is in running condition or has turned on. After that is a sound detect sensitivity adjust. Means from here, from this particular part, you can you can adjust the sensitivity and you can change it. After that is a microphone. Here is LM393 OPAMP, and this is sound detect LED. Means whenever this module senses or detects any sound, this LED is going to be turned on. So if it is turned on, means it the module has detected some sound. So these are some onboard components of this sound sensor, or you can say microphone sensor. Now let us see the working principle of microphone sensor, that how does it works. So the working of this particular sensor is somewhat similar to our ears. The way our ears sensing the sound in the surrounding medium, similarly the sound or the microphone sensor works. So the working of this microphone sensor involves converting sound waves into electrical signals. So this is the main function of this particular sensor, that it will convert the sound waves into electrical signal. It consists of a diaphragm that vibrates in response to sound waves. So particularly what happens that when it detects the sound in surrounding medium, the diaphragm will vibrate in response to the sound waves. After that, this diaphragm is connected to a coil or capacitor, which generates an electrical signals proportional to the sound wave's intensity. So, whatever intensity of that particular sound wave is there, that particular amount of vibration will occur on diaphragm, and that diaphragm is connected to capacitor or a coil. That particular capacitor will generate electrical signal, and the intensity of that generated electrical signal would be equal to the diaphragm's vibration. This electrical signal can then be amplified and processed further as per requirement or as per the usage. So this particular signal will then be amplified and processed further. So this is how a typical microphone sensor works. So these are the applications of microphone sensors, that where you can use or various application area. So first is the telecommunication. So in telecommunication, this kind of sensors are used in telephones, microphones and voice communication system. So when there are voice communication system, this kind of sensor is used. After that is audio recording. So this particular sensor is essential for capturing sound in studios, concerts and live performances. Means in the concerts or any live performance, there are this kind of microphone sensors are there. After that is speech recognition. Means this sensor is used in voice controlled systems, visual virtual assistants and voice activated devices. After that is noise monitoring. Means this is employed in environmental monitoring, industrial noise control and public safety. After that is IoT and wearable devices. So there's integrated into smart devices. This particular sensors are integrated into smart devices, fitness tracker and IoT enabled system. So these are the advanced application of the microphone sensors nowadays. Now let us see the clap switch circuit. So in this particular circuit, what we are going to do is we want a result as a LED turning on while you clap. Hence it is named as clap switch circuit. So this is a circuit. A clap switch circuit is a simple electronic circuit that allows you to control a device or appliance by clapping your hands. Means as you clap your hand, the LED is going to turn on for this particular project. You can connect any device or appliances in place of LED, but here we are using LED. It works by detecting the sound of clap or sharp noise and using it as a trigger to turn on the connected devices or turn it off. according to the command given to the particular module and the microcontroller, the connected device would work. Once you clap, it will turn on the connected device. The basic principle behind the clap switch circuit involves using a microphone to pick up the sound signal, which is then amplified and processed by the circuit. So first, microphone sensor is there to detect the sound, means the clapping sound. And after that, this particular sound signal will be amplified and processed by the other circuit components. When the sound level exceeds a certain threshold, the circuit triggers a switching mechanism to activate or deactivate the connected devices. Means when there is any extension or the the value of that particular sound exceeds a certain level, then after that a circuit will trigger, and in order or in response to this triggering process, a switching mechanism will be activated. So in switching mechanism, the connected devices would be turned on or turned off. So the hardware required to build the circuits are Arduino board, a USB A to B type cable, a laptop or computer, few jumper wires, one breadboard, one LED, one sound sensor, and a resistor. And the software which we are going to use to code our microcontroller is Blockzie. So using Blockzie, we are going to block code, and this is the circuit diagram. So as we know that we have four different pins, naming A0, ground, positive means power pins, and DO. So we are using these three pins now. So first we will connect the ground or GND pin of sound sensor module with the GND pin on Arduino Uno board. So the GND pin here is connected to this GND pin. After that is positive power pin, means this positive power pin is going to be connected to the 5 volt of Arduino Uno board, and this A0 pin of the sound sensor module is connected to the A0 or the analog pin of Arduino Uno board. So particularly we are using A0 pin. Now we are going to connect LED because the sound detected by this microphone. After that, the LED would be turned on in response to the detected sound. So we are using one LED. The cathode of LED is connected to the GND pin on Arduino board, and the anode of the LED is connected on the pin number 10 using a resistor in between. So here a resistor, and this particular LED is connected on the digital pin number 10 of Arduino Uno board. So this is how the circuit gets done. So first the microcontroller will read the signal from microphone sensor. Whatever data is given by microphone sensor to this, it will first read its analog value, and after that it will give command to LED to turn on or off as per the coding. So this is the function of this clap switch circuit. Now let us see the coding of this particular circuit. So this was about the basic information of circuit connection, and this is the code for clap switch circuit in Blockzie. So this coding part we will going to see step by step in Blockzie in some moments. So now it's time for us to see the coding for clap switch circuit. So let us start the coding step by step process. So for that, first we are going to connect and select our Arduino Uno board. So I have connected the Arduino Uno board, and now I'll just select it. After making circuit and connect your circuit using USB A to B cable to your computer or system, your laptop, Select the Arduino board and it will suggest you something like this, that yes, your device is Arduino Uno and it is connected in on this specific port. So I'll just click on connect and go to editor, and we are going to make this code in upload mode. So I have just switch over the mode from real time to upload. So first we will use the block which says when Arduino Uno begins. So this is our first event block. After that, we first clarify or declare that on which pin we have connected which device. So first is we use this particular block for input and output device. So here in case of our clap switch circuit, the microphone or you can say the sound sensor is going to be our input device, and whatever data is collecting we are collecting from the microphone or the sound sensor is going to give to our led, and in response to that signal the led is going to be turned on or off. So that is our result part. So the led over here is our output device, whereas the microphone sensor is our input device. And the microphone sensor here we have connected on pin number A0. So the pin specific A0 should have mode input, and we have connected LED on pin number 10. So pin number 10 should be as output. So the mode of pin number 10 is set on output and the A0 pin's mode is input. Now we will just clarify the baud rate, and we have set the baud rate to 9600. After that, we are going to use a forever block, because anything what we are going to do is going to show on repeat. Okay, so we are using forever block. Now first what our circuit's function is, that when there is a sound of clap, the microphone or the sound sensor first detects the sound of clapping. So the detection data should be collected somewhere, right? So for that we are going to use a variable to store the data which we have just collected from sound sensor. So we will use the sound sensor value. We are making a variable to store the data of sound sensor module and using this particular variable. So whatever the data we are getting from sound sensor as detection of sound is going to be stored in this particular variable. And after that we will the stored value will be used to turn on or off the led. So first we are using the block that set sound. First what we need to do is we need the sound sensor values to collect from somewhere, right? So we have connected the sound sensor on pin number A0, hence I will just make it read from that particular pin. So I will make this variable to read from this pin. So it will read the analog pin which is our A0 pin, and it will read the data from A0 and it will store into this particular block which is our sound sensor value. So it will store in this variable. After that what we need to do is we need, so this particular phenomena is going to be there for forever, so we are adding this in forever block. Also we need condition if and else, when the led should turn on and when it should be turned off, right? So first we have made the sound sensor values data to read from analog pin. After that it should print on serial monitor, right? Whatever the data we are getting from The sound sensor, it should be printed on serial monitor, means it should be seen somewhere. So it will be printed on serial monitor for us to see the data, right? We want to see the data which we are getting from the microphone sensor. Hence we are using this serial print, and what we need to print is whatever the sound sensor's value, right? The sound sensor value. And here it will first print the sound sensor value, and after that whatever the actual value is going to be there on screen, because we have used this particular stored variable here. So whatever the data we are getting after reading the analog pin, which is going to store in here, and that stored value will be displayed on the serial monitor using this serial block. After that we need to wait the sensor to detect whether the clap sound is there or not. So we are just adding some delay, and the delay is of 1 second only. Now we need to make a condition that what value of the clapping sound should turn on the LED, right? So we are making that condition using operator block and this particular operator block. So I'll add this particular operator block over here, that it should detect the sound sensor value, and if that particular value detected by sensor exceeds the value of 60, then the LED connected on pin number 10 should be turned on in response to detection of clap, right? Because we want to switch on our connected device by clapping. Okay, so as soon as a person claps, the LED should turn on. So I am using this condition that if the sound sensor's value exceed the value of 60, you can use 50 also. If you this value exceeds, then the LED should be turned on. Means I am using this particular block which says set digital pin output as high or low. So I want my LED to turn on, and which is particularly connected on pin number 10. So at that particular time the device here is LED, so LED should turn on, and at the same time I want that result on serial monitor also. So I'm using the serial print, and it should print that yes, sound detected, right? At the same time we need to display it on serial monitor. If the value of the sensor is less than 60, then what should happen? Then the LED should not turn on. So LED should remain in turn off. Means there is no sound of clap, or there is no clapping in the surrounding medium of sensor. Then the LED connected should stay in the off mode. So I'm using this particular block 10. And if you want to print it, then you can add this, and if you don't want to print anything, then you can just make this like this. Also we want the detected value and the LED in on mode how much time, so we can also use that and make it for some point of time. Means as soon as the sensor detects the sound of clapping, the LED should turn on for 3 seconds, right? We need to see the result. So to see the result, we are adding the delay of 3 seconds. You can use 2 seconds or 4 seconds as per your requirements. So I am using the wait block for 3 seconds. And if you want to add some additional block, then you can use this no sound detected. If you don't want this, then you can just cancel it out. Also, if you are confused, then I'm just adding it. The A0 at pin A0 is our sound or microphone sensor. And the particular component over here we are talking is our LED. This is just for the purpose of clarification, nothing else. So the particular part we have connected here is a sound sensor, and the thing we have connected as output is our LED. So this is the coding for clap switch circuit, and now you can just see that when you clap the sound, or the sensor senses clapping sound, you will see that the LED connected on pin number 10 or this LED in your circuit will turn on. So this was all about a clap switch circuit. Now you can make your own clap switch circuit in which you can add other devices or any home appliances, and you make them turn on or turn off as per your requirement. We have seen some of the basics in which we just turned on or turned off a particular device, but you can make them turning on or turning off for quite different times. You can add different time intervals, you can make them turn on or turn off using different commands, and you can make and add your taste as you want your circuit to work further. So I hope you like the video and find it useful. So now make your own clap switch circuit. We will see you in the next tutorial. Thank you so much.